Hello, talking table.
Welcome back, chemistry fans. I am so sorry for the wrong chemistry view there. Do want to let you know today's video is going to be about the shapes of the molecules. So we have a little activity that we're going to do in class today, and it starts with me in this video here. Let me share a different camera angle to where we were. And so what we're going to do is I'm going to bring out several different molecules, atoms, if you will, that are going to be placed in these bags. And along with this bag of the molecules, you're also going to see various forms of connectors. So we're going to have either springs, and the reason for them being springs, you'll see in a little bit, springs, and so you know that they are bendy if you can bend them just like that, or these wooden pegs. And so these wooden pegs, you're going to see, they will fit nicely into the holes of the bonding locations for these atoms. So either the peg can fit into the hole as such, or the spring actually can go into the hole as well. Okay. So with that, I'm going to ask you to first get out the two green spheres. And you're also going to get out one of the wooden pegs. All right, and voila, you're going to put them together, and what you're going to end up with is our first of many different molecules, and I will leave it here. And this one is called a linear, but it's got just a single atom, or it's got just a single bond in here. All right, next, what we're going to do is you're going to grab the two copper colored spheres, but you're going to grab two of these springs out of your bag. And so you're going to place the springs into the connectors, and then you're going to have to bend them to connect them into the other atom. And so what you'll see that looking like is, so here is our double bonded linear molecule. So what you see again is that two bonds were able to fit in here as opposed to just one. So that's a double bonded linear molecule. All right. Next, what you're going to get are the pinks. And the pinks are going to require, again, these springs. So you're going to need to get 3 springs, and you're going to try and convolutedly connect all of these together. And you have to bend them. You have to bend them to try and make it all connect. So let me show you how that works. And oh my goodness, there it is, magically made, even though don't worry about the different color. So here we have a triple bonded linear molecule. So we've got single bond, double bond, and now triple bonded molecules, and they all have just 2 atoms. So those are some of your options that are available to you. Next is going to be, well, what happens if we go up to 3 atoms? So what you're going to do next is you're going to grab 2 of the whites, and you're going to grab 1 of the silvers. And this time you will need 4 springs to connect to this. So it's going to take a lot of effort to make all of this. You're going to get 4 springs to connect all of these together. And what you're going to end up with is a molecule that looks something fashioned like this. And so it's very interesting how those bonds do not want to be in the same plane. They orient themselves so that they do not interfere with one another. And so they go at directly 90 degrees from one another. So they flip around, and there they are, as far apart as possible. And so we have 2 double bonds in this one, and this is also linear. Notice all of these are linear so far. I've gotten all linear, I've gotten 2 atoms, or I've got 3 atoms that are all linears. Okay, next, what I'm going to do is I'm going to get 2 of the yellows and 1 of the reds. Now we're moving away from the spheres, and we're going to move back into the pegs. So we're going to connect this all together, and what we're going to end up with is now the newest molecule. This is a bent molecule. Okay. a bent shape. Why is it bent? Because it's at this angular, but it has 3 atoms. So they both have 3 atoms, but what is making it bent? What do you notice is different? You should start to notice the double bonds that are in these versus the single bonds. The single bonds stay as these straight lines, but these double bonds tend to curve. And so they accommodate a little bit more for where the electrons are not. On this one, there are unshared pairs of electrons around this center atom. So we have linears. Now I have a bent. So that takes care of our 3. Next, we're going to go up to 4 atoms. And what you're going to need for this one are 3 of the yellows, and 1 blue. And we will connect these again with the wooden pegs. So what we're going to do magically on this one is we are going to create what appears to be just a 4-sided triangle. Well, what you need to see, though, is that it has a little bit of an uplift on it. And so this molecule does not lay flat. If I were to put this on the table and then go at an angle, what you would notice is this molecule does not touch. This blue does not touch. It's only the ends that are touched because this is raised up, because it's taking a new shape. It has 4 atoms, and this shape is going to be called pyramid, trigonal pyramid. So we have trigonal pyramid with 4 atoms. We have linears that have 2 and 3 atoms, and we have this out here, this other one, which was the bent. The bent is also out here. All right. Now there's another 4-atomed molecule, and it's going to use the black, the orange, the red, and the maroon. So we've got all the different colors, almost purple looking one. And we're going to connect all of these, but this one's going to be weird. It's going to use not only pegs, but it's also going to be using springs, which will make the double bond. So we're going to need all of this combined together to make our new molecule that will lay flat. So notice the shape of this one in comparison to the other one. They both have this triangle shape, so they're called trigonal, but one of them we showed does not lay flat, as opposed to this one, it is able to lay flat, where all 4 of the atoms can lay on one single plane. So as we notice on this one going sideways, one lays flat and the other one is raised up. This left one, this is called trigonal pyramid, we've already discussed. This is now called trigonal planar. And what you should notice, the difference between these is the fact that we have a double bond. The double bond is the difference. These springs, there is not a double bond in the trigonal pyramid. It has all single bonds, but the trigonal planar is going to have a double bond on one of the atoms. All right, the last, you're going to get 4 of the spheres, 4 of the yellow spheres, and you're going to get 1 black. All of these are going to be connected with the wooden pegs. And what we're going to end up making is a unique, only because it has all single bonds. It is the only molecule that has 5 atoms. This is called a tetrahedral. Tetrahedral has 1 atom that sticks up away from it. It has at its heart a pyramid shape down here, but it has 1 more on top. So if we were to look at this one from the side, what you would see is how it raises up off the surface, just like the pyramid did, but it has 1 that comes up higher than that. And so now, if I'm taking a picture of this whole thing, which is what you should also be doing, you need to have all of these on a piece of paper and label what each one of the different shapes are. So this is the task at hand. This is what we are trying to accomplish today in your activity. So thank you very much for paying attention. We'll talk to you again soon. Bye-bye.